Hello, in this video, we will be discussing the addition and subtraction rule of differentiation. This video is a continuation of the basic rules of differentiation. So you may refer to this video up here. To serve as a quick recap, we already learned the first rule. If y equals ax to the power of n, then dy dx equals, bring the power down, multiply it with the existing coefficient, write the variable back, and subtract 1 from the power. And we've also learned if the function is a constant function, so let's say if y equals c, that means the y dx will be equal to 0. These are the two rules we have learnt so far. So you may refer to the video in the description below to see the detailed explanation on these two rules and how to apply them. Moving on to this rule 3, which is the sum and difference rule. Basically, what the sum and difference rule actually entail is nothing special. It's just the application of rule 1 and rule 2, just in the form that the function in of itself has addition and subtraction signs. So what do we mean by that? If we go from this equation that we have here, the equation says if y equals ax to the power of n, we know what to do. We apply this. The y dx equals n times a into x raised to power n minus 1. But now what if the function is plus or minus another value, let's say b x to the power of m? So how do we do that? Well, it's basically the combination of the first rule and the second rule. In this situation, just the combination of the first rule alone. So we just take the respective derivative of each value, that is, the y dx will be equal to, take the derivative of this first part here, we will have derivative of ax raised to power n with respect to x plus or minus derivative of bxm with respect to x. Here we also say with respect to x, we have to put the change there, with respect to x. So that's what the sum and difference rule is just about. This may look ambiguous, but let's use numbers to explain what is going on here. So bear with me for a second. Just two quick examples so that you can understand how to apply what we've written here. The question says, find the derivatives of these functions with respect to x. So the first question says, y equals 3x squared plus 4x to the power of 5. So the y dx, derivative of y with respect to x, or we can call it y prime, is equal to, we take the derivative of this 3x squared with respect to x. That is, we apply this first rule that we know. So which means, let's open the parentheses to make it clear. We bring the power down, which is 2. Multiply it with the existing coefficient, that's 3. Subtract 1 from the power, 2 minus 1. Again, what we did, we took the derivative of this first part of the equation here, which is 3x squared. We differentiated it with respect to x. So we brought the power down, which is 2. Multiplied with the existing coefficient, which is 3. Write the variable back again, x, and then we subtracted 1 from the power. Close the bracket. Plus, do exactly the same thing to the second part of the equation also. So we take derivative of 4x raised to power 5 with respect to x. So we bring the power down, which is 5, multiply it with the existing coefficient, which is 4, multiply it with the variable, which is x, subtract 1 from the power. So 5 minus 1. And that concludes the second part. So that means the y dx, differentiation of y with respect to x, equals 2 times 3 will give us 6. X, 2 minus 1 is 1. So x raised to power 1 is still x. So we leave it like that. Plus 5 times 4 is 20. X, 5 minus 1 is 4. So we have 20x to the index of 4. So 20x raised to power 4. And that's the answer. Again, what we did was we took, to get the y dx, take derivative of the first element or the first part of the equation with respect to x plus the symbol that is in the question. Take the derivative of the second part of the question with respect to x, and that's it. So what we applied was this first rule here. Again, if you would like to understand this first rule here, please refer to the video in the description. We explained this first rule in detail, and we gave 10 examples dealing with the first rule and the second rule. Next to the second question, y equals 10x cubed minus 7x. Let's add plus 5 to the question, plus 5, so that we may apply the second rule also. The y dx equals, like we said previously, we take derivative of this first part with respect to x. So for simplicity, let's open a big bracket. So to differentiate 10x cubed with respect to x, we bring the power down, which is 3, multiply it with the existing coefficient, which is 10, write the variable back, which is x, subtract 1 from the power, that will give us 3 minus 1. Close the bracket, we are done with the first part. The sign, which is negative, minus. Next, we take the derivative of 7x with respect to x. So let's open a big bracket again. Derivative of 7x is we bring the power down. The power of this x here is 1. So bring the 1 down. Multiply with the existing coefficient, which is 7. Multiply with the variable, which is x. And subtract 1 from the power. So we have this. Close. Plus, now we take derivative of this 5 here with respect to x. As we can see, this 5 does not have any x, which means we are applying the second rule here because it is a constant. And as we've learnt before, when we take derivative of a constant with respect to a particular independent variable, if the value does not have the independent variable beside it, then automatically the answer is 0 by default. So let's simplify. The y dx equals 3 multiplied by 10 is 30. X, 3 minus 1 is 2, minus 1 times 7 is 7. X, 1 minus 1 is 0, plus the 0. So the y dx equals 30x squared minus 7. X raised to power 0 is 1. Any value raised to power 0 is 1 plus 0. So that means we have the final answer is 30x squared minus 7. And that's the answer. Now we are going to do 10 practice questions in order to help us understand or to better our understanding about everything we've learned so far on differentiation. Let's look at the practice questions one by one and explain in detail. Take the derivatives with respect to x. Solutions. The first question, y equals 3x squared plus 10x minus 8. The y dx equals, as we've explained earlier, we take the derivative of this first part, which is 3x squared, with respect to x. So that means we bring the power down. Let's open a big bracket. We bring the power down, multiply it with the existing coefficient, which is 3. Write the variable back, subtract 1 from the power, plus derivative of this second part with respect to x. So we differentiate 10x with respect to x. We will have, bring the power down, which is 1, multiply with the existing coefficient, which is 10, write the variable back, subtract 1 from the power. Close it. And then the last part minus derivative of 8 with respect to x. We will have 0 because 8 has no x, so it is a constant. So the y dx equals derivative of y with respect to x equals 2 times 3 is 6, x, 2 minus 1 is 1, plus 1 times 10 is 10, x, 1 minus 1 is 0, minus 0. Hence, the y dx equals 6x raised to power 1 is 6x plus 10. X raised to power 0 is 1 minus 0. So we have the y dx equals 6x plus 10 times 1 is 10. And any value minus 0 is that value. So 6x plus 10 minus 0 is 6x plus 10. So this is the answer. Now, this part that we have written in this color brown here is just for your understanding. Usually, we can go from this question directly to this answer. So we can go from the question directly to the answer. All of this here can be done in the head. So you don't need to show this boxed part here, except if otherwise stated by the examiner. So in subsequent question, we will do this step in the box orally, just to save time and just to increase the rate of the understanding. So you may always refer back to this step here in case you get lost in our explanation in subsequent questions. And also you can follow through with a voice, and we will explain how we go through each step one by one verbally. So there should be no problem. Second question, y equals negative 10x raised to power 4 plus 2x cubed plus 11. If you've seen the previous video or the previous lecture on Rule 1 and Rule 2, you will understand that we first need to sort out a certain thing. We need to sort out this x cubed. Why is that? Because x cubed is at the denominator here. Because we are not applying quotient rule, as we've not learnt it, or there is no reason to apply a quotient rule here because the function is quite simplified. So we need to find a way to bring this x cubed back to the top here. So because we can't differentiate a function with respect to a certain independent variable that is at the denominator, except when applying a quotient rule. But we are not applying quotient rule here, so we need to find a way to bring this x cubed back to the top here. So let's sort that out. To sort it out, we'll have y equals negative 10 x to the power of 4 plus, so if this x cubed is going to come up, it's going to become 2x to the power of negative 3 plus 11. How did we do this? To jog your memory, remember that we said if x raised to power negative a, then it is equivalent to saying 1 divided by x. Now that we've brought the x down, we get rid of the negative sign, so the power becomes positive. So we can go from this to this, or we can go from this back to this. So for this question, we went from the fraction back to this. That's what we applied. Now, we can take the derivative of this function with respect to x without any issue. So dy dx, or y prime, equals to, the power here is 4. So 4 multiplied by negative 10 will give us negative 40. We write the variable back, subtract 1 from the power. So 4 minus 1, that will give us 3. Again, bring the power down, which is 4. Multiply with the existing coefficient, which is negative 10. So 4 multiplied by negative 10 will give us negative 40. And then write the variable back and subtract 1 from the power. Plus, the index here is negative 3. The power here is negative 3. So bring the power down, which is negative 3, multiplied with the existing coefficient, which is 2. So negative 3 multiplied by 2, that will be negative 6. So we have negative 6. Write the variable back, subtract 1 from the power. So minus 3 minus 1 will be minus 4. Plus, differentiate the last part, which is this 11, with respect to x. So 11 differentiated with respect to x will be 0. So that means dy dx equals minus 40x cubed positive multiplied by negative will give us negative. So we have negative 6 x to the power of minus 4, and any value plus 0 is that value. So we leave the answer like this, or you may rewrite the answer in the form that the function was given to you, which is dy dx equals negative 40x cubed. So we bring this x raised to power negative 4 down. So that means we'll have negative 6 divided by. So now we go from this to this. At the top here, we go from x raised to power minus a back to 1 divided by x raised to power a. So we have minus 6 divided by x. When x comes down, this negative symbol here will turn to positive, or will be gotten rid of, and we'll be left with 4. Hence, the answer, the solution, has been written back in the way the function was given to us. And as I've always mentioned, there is no problem. It's totally okay, absolutely okay to leave your answer like this. There will be no penalty from the examiner, except if otherwise stated. The next question, question 3, says t equals cube root of x plus 10 minus square root of x cubed. So question 3, t equals cube root of x plus 10 minus square root of x cube. Yes, as you can notice, we need to sort out this issue here. We need to sort out this issue here because in order for us to apply the rule that we've learned so far, we need to write these elements or these values here in a way that we can apply the rule, in a way that we can bring the power down, multiply with the existing coefficient, subtract 1 from the power. So that means t equals, now the rule we are going to be applying is if we have x to the power of m, but it is also to the root of n, that means it is equivalent to saying the variable which is x raised to the index which is m divided by the roots we are taking. So nth root of x raised to power m is equivalent to x raised to power m divided by n. So applying it here, we will have x. The power of x here is 1, so that will be 1, and the nth root is 3, so we have divided by 3. A cube root is nothing but the variable or the value raised to power 1 over 3 plus 10 minus, again, we applying this rule here, we will have x, the power is 3, and the nth root is 2 here, but it is not usually written. So we have 3 divided by 2. So a square root actually means 1 over 2. But because the power here is 3, we will have 3 over 2. I hope that is clear. You may rewind and listen to the explanation again if that is not clear. Moving on, now we can take the derivative of this function with respect to x. Since this is involving fraction, to make it clear, we will go in detail. So let's start the t dx. So derivative of this t function with respect to x equals, we can call it t prime equals, open the first bracket because now we're taking derivative of this first part with respect to x. We are taking derivative of x raised to power 1 over 3 with respect to x. So applying the rule, it means we bring the power down, which is 1 over 3, multiply with the existing coefficient. The existing coefficient here is 1, so we can ignore it because 1 divided by 3 times 1 is 1 over 3. Write the variable back, subtract 1 from the power, that's the first part, plus the second part, derivative of 10 with respect to x. Because 10 has no x, so we treat it as a constant. So that means derivative of 10 with respect to x will be 0 minus the last part, derivative of x raised to power 3 over 2 with respect to x is, bring the power down, which is 3 over 2, multiply it with the existing coefficient. In this case, the existing coefficient is 1, but it's not written, so 3 divided by 2 times 1 is 3 over 2. Write the variable back and subtract 1 from the power. So that means the t dx or t prime equals 1 over 3 x, 1 over 3 minus 1, this place here. 1 over 3 minus 1 is 3 times minus 1, that's minus 3. 1 minus 3 is minus 2. So 1 over 3 minus 1 is minus 2 over 3 plus 0, that can be ignored, minus 3 divided by 2, 3 over 2 x, 3 over 2 minus 1, that's 2 times minus 1, that's minus 2. 3 minus 2 is 1. So that means the answer is raised to power 1 over 2. Of course, you can leave your answer like this, or you can take it a step further. To avoid causing any confusion, since our topic is derivative, let's just leave it like this. So you may leave your answer like this, that's fine. Next question, question 4 says W equals negative 8 divided by 7x raised to the power 4 minus 1 divided by square root of x. So question 4, W equals negative 8 divided by 7x to the power of 4 minus 1 over square root of x. First thing first, we need to find a way to bring this s raised to the power 4 to the top. As we've explained before, we can't take derivative with respect to a variable that is at the denominator. And also, we have a double problem here. This has a root, and also we need to bring it back to the top before we can take the derivative. So let's sort it out. W equals negative 8 over 7. If this x raised to the power 4 comes to the top, that means it will be x raised to the power negative 4. So when this x raised to the power 4 goes to the top, the power, which is 4, will become negative. And if the power is coming from the top down, then it becomes positive. Done with the first part, minus. The second part is having a root. So let's get rid of the root first. So we have 1 over x in root form, because the power here is 1 and the nth root is 2. So that means we have 1 over 2. So W equals negative 8 over 7 x raised to the power negative 4 minus. Now that we've gotten rid of the root in the second part, now we can bring this x to the top here. We will have 1 multiplied by x. When this comes up, it becomes negative 1 over 2. To simplify, we have negative 8 over 7 x raised to the power minus 4 minus 1 times any value is that value. So we have x to the power of 1 over 2. Now we can take the derivative of W with respect to x. So the W dx, which is same as W prime, equals the first part, which is this. We take the derivative with respect to x. So we bring the power down, which is negative 4, multiply with the existing coefficient, which is negative 8 over 7. Write the variable back, subtract 1 from the power, negative 4 minus 1, close it, minus, take the derivative of this second part here, x raised to the power negative half with respect to x. We will have, bring the power down, which is negative 1 over 2, multiply with the existing coefficient, which is 1, write the variable back, subtract 1 from the power, so negative half minus 1, close. So the W dx or W prime equals negative 4 multiplied by negative 8 over 7. So negative times negative is positive. 4 times 8 is 32. So we have 32 over 7 x minus 4 minus 1 is minus 5 minus. Now we have a minus here, but we have another minus inside here. So we have minus 1 over 2. So minus will give us positive. So let's get rid of the minus and write them as positive. because minus times minus will give us plus. So plus 1 over 2 x minus 1 over 2 minus 1, that's 2 times minus 1, that's minus 2, minus 1 minus 2, that will give us minus 3, so we have minus 3 over 2. And that's the answer. Of course, we can take it a step further, but it's okay if you leave it like this, except if otherwise stated. Next question, question 5, says f of x equals 5 into x squared plus 2x. Question 5, f of x equals 5 into x squared plus 2x. First, we have no problem, we have no denominator, and we have no roots. So we can take the derivative of this function directly. However, the issue we have here is that we have this 5 outside. So this 5 is outside of this bracket that we have here. There are two ways we can go about this. Either we apply the product rule, which we are yet to learn, or we open up the brackets so that we can take the derivative without the need of a product rule. So let's open the brackets. That means we have f of x equals, we multiply this 5 with this x squared, and we take that same 5 again, multiply with this 2x. That's the way we open the bracket. So 5 times x squared is 5x squared plus 5 times 2x is 10x. Now we can easily take the derivative without the need of a product rule because the function is in a form that can be solved with the basic rule that we have learned so far. So we are taking derivative of the function with respect to x. So derivative of f of x with respect to x equals to, we can write this as f prime x. So the f of x dx is the same thing as saying f prime x equals taking derivative of 5x squared with respect to x, that's 2 times 5, which is 10. Write the variable back, subtract 1 from the power. 2 minus 1 is 1, so we leave it as 10x. So derivative of 5x squared is 10x plus derivative of the second part here, which is 10x. So the power here is 1. Multiply with the coefficient, which is 10. So 1 times 10 is 10. Subtract 1 from the power. So 1 minus 1 is 0. So x raised to power 0 will be 1. Hence, our answer is 10x plus 10. You may review the question again, or you may rewind back to listen to how we verbally solved the question. Next question, question 6. F of x equals 3 minus 5x plus 2x squared. Question 6. F of x equals 3 minus 5x plus 2x squared. Looking at this question, we have no issue of a denominator, we have no issue of a root, and we have no issue of a bracket. Hence, we can take the derivative straight. So, taking the derivative f prime x, which is the same thing as the f of x, derivative of the function x, with respect to x, equals the first part here, which is 3. When we take derivative of 3 with respect to x, the 3 has no x, hence the answer is 0. It is a constant. So derivative of 3 with respect to x is 0 minus derivative of this second part here, which is 5x with respect to x. That will give us 5 plus derivative of this third part here with respect to x, derivative of 2x squared with respect to x. That will give us 4x to the power of 1. So the f of x dx equals negative 5 plus 4x. Next question, question 7. P equals x plus 1 into brackets x minus 9. Question 7. P equals x plus 1 open brackets x minus 9. Yes, you guessed right. We have a problem of brackets here. And since we are not applying product rule, so we need to find a way to get rid of this bracket. So to get rid of this bracket, what we simply do is that we take this x, we multiply it with this x here, and we take the same x again, multiply it with the 9. That's the first part. And then we take the 1, multiply it with x, and then we take the 1 again, multiply it with negative 9. So let's go one by one. P equals x multiplied by x is x squared. X again multiplied by negative 9 will give us negative 9x. We're done with the first. Take this plus 1 here, this positive 1, multiply it with x. We'll have positive 1 multiplied by x will give us positive x. Again, take this positive 1 again, multiply it with negative 9. So positive 1 multiplied by negative 9, that will give us negative 9. So you may take your derivative in this form, or you may simplify further. Let's simplify further. So P equals x squared negative 9x plus x will give us negative 8x, and we're left it negative 9. Since no simplification can be done anymore, we can take the derivative. So derivative of the function p with respect to x, we may call it p prime, that's equal to derivative of this first part, which is x squared. Derivative of x squared is 2x. Derivative of negative 8x is negative 8, and derivative of negative 9 is 0. So there is no need to write it, and that's the answer. Next question, question 8. Y equals 3x minus 4 all squared. Y equals 3x minus 4 all squared. As you notice, we have a problem of a bracket and we have a problem of all squared outside here. So there are two ways we can approach this problem. We can either use what is called the chain rule, which we will learn later. But since we are yet to learn the chain rule, we need to break down or simplify this function in a way that we can apply the basic rules we have learned so far. So to simplify it, y equals 3x minus 4 all squared simply means we multiply 3x minus 4 by itself twice. For example, when you have 2 squared, 2 squared means multiply 2 by itself twice. If you have 3 squared, it means multiply 3 by itself twice. So you have 3 times 3. If you have 5 squared, it means multiply 5 by itself twice. 5 times 5. So 3x minus 4 all squared simply means multiply 3x minus 4 by itself twice. So we have 3x minus 4 multiplied by 3x minus 4 again. Now we've gotten rid of the square because we are not applying chain rule, but now we have another issue now because now we have multiplication, which means we need to apply product rule, which we are yet to learn. So we need to simplify this further and get rid of the brackets. So we will have y equals, take this 3x, multiply it with the 3x. So 3x times 3x will give us 9x squared. Take the 3x again, multiply it with minus 4. You will have minus 12x. Take minus 4, multiply it with 3x. You will have minus 12x. Take the minus 4 again, multiply it with minus 4. You will have plus 16. If I've lost you, you may rewind back. Next, we can take the derivative straightforward, or we can simplify further because we have x here, we have x here. So we can do a summation here. So taking it a step further, y equals 9x squared negative 12x negative 12x minus 12x minus 12x is minus 24x plus 16. Now we can take the derivative of y with respect to x. So we will have the y dx equals y prime equals, the y dx is the same as saying y prime. So y prime equals, take derivative of this first part here, which is 9x squared with respect to x. We will have 18x minus, take derivative of 24 with respect to x. You will have 24 plus, take derivative of this last part here, which is 16 with respect to x. The 16 has no x, so the answer is 0. So that's our answer. When we got here, I said you can take the derivative without any need of simplifying further. What did I mean by that? Let's take the derivative and see. The y dx equals derivative of this 9x squared with respect to x. That will be 18x derivative minus derivative of this 12x with respect to x. That will be minus 12. Derivative of this negative 12x with respect to x. That will also be minus 12. And derivative of this last part, which is plus 16 with respect to x. That will be 0 plus 0. So that means the y dx equals 18x minus 12 is equal to minus 24 plus 0. And you can see we have the same thing. Next question. Question 9. Question 9 says y equals 2 over x plus square root of x plus 3x squared plus 5. Question 9, y equals 2 over x plus square root of x plus 3x squared plus 5. We have a few issues to sort out here. First, we need to bring this x back to the top. Second, we need to get rid of these square roots. And then we can take the derivative of the function with respect to x. Let's sort it out. So y equals 2. Bring this x to the top here. X. The power of x here is 1. So that means when it comes to the top, it becomes negative 1 plus square root of x means x raised to power 1 over 2. The power here is 1 and the index here is 2. So when they transform, it becomes 1 over 2 plus 3x squared plus 5. Because we have fraction and negative sign here, We will take our time to explain so that you understand without any mistakes. So dy dx equals the first part, open a big bracket, bring the power down, -1, multiply with the existing coefficient, which is 2, write the variable back, subtract 1 from the power, so -1 minus -1, done with the first part, plus the second part, x raised to the power 1 over 2, bring the power down, that's 1 over 2, multiply with the existing coefficient, which is 1, write the variable back, x, subtract 1 from the power, so 1 over 2 minus 1, done with that, plus the next part, which is 3x squared, bring the power down, which is 2, multiply with the existing coefficient, 3, write the variable back, x, subtract 1 from the power, so 2 minus 1, and done, plus the last part here, 5. Differentiate 5 with respect to x. This 5 has no x, so the answer is 0. Hence the y dx, or y prime, equals -1 times 2 is -2, x minus 1 is -2, plus 1 over 2, x, 1 over 2 minus 1, that's 2 times -1, minus 2. 1 minus 2 is -1, so we have -1 over 2, plus 2 times 3 is 6, x, 2 minus 1, that's 1, so done. That's the answer. Next question, the last question actually. Question 10. F of x equals -6x minus 12. Question 10. F of x equals -6x minus 12. First, we have no denominator, which has an independent variable, so no problem there. We have no square root, no problem there. We have no brackets, no problem there. So we can take the derivative without having any issues. So we can take the derivative with respect to x directly. The f of x dx, derivative of the function x with respect to x, is the same as saying f prime x, and that's equal to -6. As simple as that. Thank you very much for watching. I hope you found this video very beneficial and it helped you understand the sum and difference rule of derivatives. You may refer to the playlist here for more videos on the rules of differentiation. See you in another video. Thank you very much.